Alright, hey guys, I just want to do a quick bonding summary with you over ionic, covalent, and metallic bonding. So I made a little comparison chart here to kind of go over what the main properties of each of these kinds of bonds are. First, ionic. It's when you have a metal and a non-metal. And if you remember on your periodic table, your metals are over here, your non-metals are over here, with the exception of hydrogen. Hydrogen's a non-metal. So if you have a metal and a non-metal together in a bond, it's an ionic bond, okay? Covalent is when you have two nonmetals. Metallic is when you have a metal and a metal. Now, some kids get confused by metallic bonds because we don't really talk about metallic bonding in the same way like we would talk about an ionic or a covalent bond. And that's because when metals combine, like if you have, a copper atom and another copper atom, they're technically are sharing electrons. Remember the delocalized electrons, the sea of electrons we talked about? They're kind of sharing those delocalized electrons, and those electrons are free flowing over the surface of the metal. But metals don't combine in exact ratios the way that ionic and covalent bonds do. So we more talk about metallic bonding in terms of what properties they give metals. Anyway, so I just want to clear that up. But ionic bonding is when you transfer electrons. So you've got something that wants to give up electrons, you've got something that wants to gain electrons. And again, if you remember, like on your periodic table, all the atoms on the periodic table can become more stable if they have a full octet, like the noble gases. So like fluorine here wants to gain one more electron to be like neon, and let's say like sodium wants to lose one electron to be more like neon. So if sodium and fluorine come together, fluorine can say, hey, I'll give you my electron, you take my electron. Now there is a separation of charges, and it forms a cation and anion, and that electrostatic force between those two is what keeps the ionic bond together. In a covalent bond's two nonmetals. So all these nonmetals here, they don't want to lose electrons, because if they lose electrons, they'll be less stable. They want to gain electrons because they're really close to the noble gases. So because they both want to gain electrons, they share. And like oxygen might come to nitrogen and say, hey, we can share our electrons, and then we can both become more stable. So that's why covalent bonds are sharing electrons between nonmetals. And again, metallic bonds, it's when the electrons are shared, but it's more like the electrons are free flowing. They're delocalized, meaning they're not stuck to one particular spot. They're free to flow across the surface of the metal, which gives them these properties like conducting electricity. We know metals can conduct electricity very well. Covalent substances do not conduct electricity, okay, because there's no electrostatic force. Those electrons are being shared. No one's trying to give up electrons, so they don't conduct electricity. Now, ionic compounds, if you remember, they conduct electricity sometimes when they're melted or when they're dissolved in water, meaning in solution, okay? So if they're in solution, think about like salt water. Sorry, that shouldn't be one word. In solution, two different words. When they're in solution, meaning they're dissolved in water, they can conduct electricity. If you remember at the beginning of the year, we talked about that's why you don't want to go swimming in a lightning storm, right? Because there's lots of things dissolved in your swimming pool. Lots of different ionic compounds are dissolved in there, and it will conduct electricity. Brittle. Okay, so ionic compounds tend to be brittle, meaning they will bend and break. I mean, they won't bend, they will break. Whereas metals, they're malleable, ductile, lustrous, all those fun words we've talked about before. You can bend metals, you can shape them into different shapes and stretch them out. They tend to be shiny and reflect light, and that all has to do with the fact that they have these sea of electrons, these electrons that can move over the surface of the metal. Okay, and covalent substances, they can be solid, liquid, or gas. So ionic compounds tend to be solid at room temperature. Metals, same thing. There are some exceptions, but generally. Covalent substances, think about like H2O. That's a covalent substance. That tends to be a liquid at room temperature. But if you have, something like oxygen gas, that's obviously a gas. So there's different, or carbon is a solid. So all these different states of matter for covalent substances. Crystal lattice structure, that's what ionic compounds form because they have these positive and these negatives that kind of hook up together, and they create this structured crystal lattice structure. These are just like extra facts. Covalent substances can be polar or nonpolar. We're going to talk about that more here in a second. So if you ever hear the term polar bond or nonpolar bond, that's referring to covalent substances, okay? And metallic, so it says that metals can alloy. So if you take like copper and tin and you melt them down together, you mix them together, they can form what's called an alloy, okay? It's just like a mixture of two metals. That's where you get your alloys such as like brass or bronze or steel. Those are types of alloys, okay? Metals have very high melting points. Their melting points get even higher as their electrons get more delocalized. So like your transition metals tend to have the highest melting points. Covalent substances have low melting points, and a lot of that has to do with the fact that they can be any, solid, liquid, or gas. And ionic compounds also have high melting points, okay? So that's something to keep in mind. Let's talk about bonding, or polarity real fast. Okay, so in an ionic bond, an electron is just transferred, right? So this atom sees this atom, and this one's like, hey, I'll give you my electron. So it gives its electron up, and now there's just like this force between them, this positive and negative electrostatic force between them. But the electron is just straight up transferred from one to the next. Okay, now in a polar covalent bond, remember if it's covalent, by definition, it means the electrons are being shared. Okay, so they're sharing, but they're not sharing super equally, right? This guy's hogging the electrons, so he gets the electrons more often than this guy, and that's because he has a higher electronegativity. It's an unequal sharing in a polar covalent bond. Okay, in a polar covalent bond, it's an unequal sharing of electrons. And do you remember this weird little symbol here? This weird little symbol means partial. So this is a partial negative. It's not a full-blown negative charge because they didn't transfer the electrons. Because he's hogging the electrons most of the time, it's almost like he has like a pseudo-negative charge over here, and he has a pseudo-positive charge over here. Okay? Whereas a non-polar covalent bond means that they are shared equally. Okay? Those electrons are shared equally. So this tends to happen in atoms that have very similar electronegativities. Okay, so when the two atoms have similar electronegativities, or the same. So like if you had two of the same element, like a fluorine and a fluorine, their electronegativities are exactly the same, so no one's going to hog. But if you have a difference of electronegativities, like a big difference, then remember electronegativity means they're greedy. So he's going to, if he has a higher electronegativity, he's going to hog the electrons more, and that's how you get a polar bond. Now, on your comps, this is going to be similar to pre-comps. The rule that we want you to know, because if you remember, I told you about how you can actually look up the electronegativity values, and you can actually subtract them and figure out electronegativity difference. But on comps, I'm not going to expect you to do that necessarily, okay? What I just want you to know, if you remember from pre-comps, is that assume, so you're going to assume that every covalent bond is polar, except carbon bonded to hydrogen, because their electronegativities are really similar, so that would be a nonpolar bond, and anything bonded to itself, anything to itself. So these things would be nonpolar. Okay, so these would be your nonpolar scenarios. Nonpolar. Okay, so it's carbon bonded to hydrogen, assume it's nonpolar. If it's anything bonded to itself, like a hydrogen and a hydrogen, or a fluorine and a fluorine, anything bonded to itself, assume it's nonpolar. Everything else for covalent bonds, assume they're polar. Okay? Okay, now I just want to do a quick little practice problem with you. Okay, which would have a higher melting point? This is the type of problem you might see on your comps, okay? Which would have a higher melting point? So you have NaCl and CCl4. So first thing I would look at is say, okay, what type of bond is this? This is NaCl. Well, I can look at my periodic table and I know Na is a metal, Cl is a nonmetal. So that must be ionic. And this is CCl4. Well, carbon is a nonmetal. Fluorine is also a nonmetal. So because they're both nonmetals, they must be covalent. Now, if you remember, which has higher melting points, ionic or covalent bonds? Let's see. High melting points. Ionic has high melting points. Covalent does not have high melting points. So this one would be your answer. Okay, that would be your answer because ionic compounds have higher melting points than covalent compounds. And then for this second one, which one would have a higher melting point? Well, let's figure this out. NH3, what type of bond is that? Nitrogen is a nonmetal. Hydrogen, even though it's over here, remember hydrogen's an exception. Even though it's over here with all the metals, it's not a metal. Hydrogen's not a metal. So because it's a nonmetal and nitrogen's a nonmetal, that's going to be a covalent bond. And this other one is weird. CuZn, what even is that? That sometimes shows up on comps. That's basically implying, hey, this is an alloy between copper and zinc. They took some copper, took some zinc, and it doesn't really matter what the ratio is. They melted them down, and so this is a metal and metal. So this would be considered metallic bond. Both copper and zinc are metals. So which has a higher melting point, covalent or metallic bonds? Metallic. Okay, so that's how you would figure that out. Alrighty, go ahead and do the assignment.